All right, let's go ahead and make some art. I think starting with trying to make a checkered board like this is a great first project. So let's try to do it. Because I'm going to be using some external packages to help with the drawing, I'm going to create a package.json file to pull them in. And the package I'm going to be using is called Canvas. I'll just grab the latest version. And then because I'm going to be using TypeScript, I'm going to pull in the node types as well. And we can install those packages just by running npm install. All right, now we can get to work writing some code. So again, the goal is going to be to create something like this. Let's get started by seeing if we can generate an image at all. So I'm going to be using the create canvas from that canvas package that we downloaded. And then let's actually write a draw function so that we can reuse this. Yeah, in the first step, we want to create a canvas. This will create a 200 by 200 canvas. This will get the canvas context so that we can actually start drawing. This will draw a green rectangle starting pretty close to the top left, just 10 pixels off. And then we actually want to output this to an image file. So we'll grab the buffer as a PNG, and then let's actually import FS so that we can save this as a file. Yep, that's exactly what we want to do, except I'll just rename this to board. And then let's call this. All right, let's see if this actually worked. Awesome. Yeah, we got a 200 by 200 image, and we have a 100 by 100 green rectangle placed 10 pixels from the top left. That's a great place to start. All right, the next thing I want to do to get closer to actually drawing that checkered board we started with is let's see if we can update this draw function to take in a two-dimensional array and draw it. So I'm thinking that this would look something like something like this. I guess this would be a 3x3. And then this would draw a white square, black square, white square, and so on. All right, how do we do that? Well, we need to iterate over, exactly. Let's iterate over that array, iterate over that array. I don't want to do this, but I think what this is trying to do is do 30 by 30 rectangles here. So actually that would be a useful parameter to have. So let's pass that in as well. This will just let us control the size of the squares that we're drawing. And sure, let's make those 50 pixel squares to begin with. So yeah, we're setting the fill color to whatever that value is that we passed in. So this one, the fill color would be white. This one, the fill color would be black, and so on. And then we just, need to draw the rectangle based on that cell's position in the array. Yeah, I don't want this plus 10 offset. This is what we want. And then, the width is just cell width, and the height is cell width. And we can clean up this. We don't need this anymore. I think that should do it for us. Let's go ahead and run this and see if we get a checkerboard. Boom, we do. You'll see though that this doesn't fill up the full square because the full image because we have a 200 by 200 image. So we should actually dynamically compute what we want the canvas width and height to be. So the height, it's just gonna be that, and the width will be that, and then update that. Awesome. Let's see. Sweet. And let's make sure this is actually doing what we want. Let's put a green square in the middle and a red square in the bottom right. Sweet. And let's see if it's actually correctly dynamically computing the height by adding another row. Excellent. Okay, so now we can actually draw the checkered board. We are manually constructing it here though. The next thing I want to do is see if we can construct this array algorithmically instead of by hand. Let's make a new function where you can pass in the number of rows, the number of columns. I don't want to start with the default color. Let's get rid of that for now. And then it should return an array like this. So let's start with an empty board. And then, yep, let's iterate through all the rows, all the columns. Dang, that's perfect code that just spit out. Okay, so what this is doing is it's going to loop through for the number of rows that we have, create a new row each time and add it to the board. And then for each row, loop through all of the columns. And then we're going to alternate between populating it with white and black. So calling this function should construct something very similar to this board that we constructed by hand. So let's get an 8x8 board. Let's see if this works. Awesome. And the great thing about constructing this programmatically is that we can do any dimensions we want. I can create an 80x80 board, and it's not any more difficult than creating an 8x8 board. Put whatever number you want here. I think the 8x8 looks good though, so let's stick with that for now. The other cool thing is that you can play with this in all sorts of ways. Like if instead of white and black, I want red and blue, I just update that. That's all I gotta do. You can even get fancier with this and you rewrite the way this is expressed. So same logic there. So this is equivalent. This is just syntactic sugar for that. But this will allow me to riff on this a bit more. So let's say we want to do every 3 squares change color instead of every 2. Then I could do something like this, exactly. And now we'll go red, green, blue, red, green, blue. You could extend this even more if you want. Let's go back to the way it was though. And let's just do black and white again. That's an interesting pattern. That's because I'm doing mod 3. So this is actually, we're only doing white every third. So it should go white, then 2 blacks, then white. I didn't mean to do that, but that is another interesting pivot on this. There you go. That's the original checkered board. You could also, let's do one with a random color instead of black. Let's make another function for getting a random color. Perfect. And then instead of the black, let's do the random color. Or another variation you could do on this is you could make the black gradually fade out as we get towards the bottom of the screen. So to do that, let's see. Let's make a %white variable that's going to start off at 0. So we're going to start being all black. And then each time we add a square, let's adjust the %white. Let's tweak up a bit. 8x8, we have 64 squares. So let's bump this up by something like, I don't know, 0.012. So we don't get all the way to 100% white by the time we get to the bottom of the board. And now all we need to do is update this to get some gray color based on the %white that we have. So let's implement that function real quick. Yeah, that's perfect. You could make this a little more robust by, if you get passed in a value outside the range 0 to 1, you could crop it off, you know, something like if, yep, do this. just so you don't end up with some nonsense value. Yeah, and then so let's see if this works. This should just, bam. So we just slowly fade as we get down the screen. All right, last variation I'm going to do is let's do circles. Let's do circles instead of squares. So this is where we're actually drawing the squares. It's not hard to update this to do a circle instead. We just do a path, and then we do an arc here. And we want this to start. See, we want to do x times cell width. That's the beginning of this. Yeah, here's what we want. But then the center is going to be in the middle of the square, so we bump that over. What is this value? Yeah, the radius. We actually want the radius to be cell width over 2. That's funny that it wants to do it over 4. Yep, and then 2 pi for the full circle. And then we just want to fill that thing in. And we don't need this anymore. All right, let's see if that works. So that should be circles instead of squares. Boom. That's kind of nice. I kind of like that. All right, so let's close this out. And here's the final product that we came up with. So that's your introduction to making algorithmic art. I'm going to link to all this code, so go check it out and feel free to make any modifications that occur to you.